White text in a purple box. I am CSE, Melanie Sclar, Natural Language Processing. Small white text, Paul G. Allen School of Computer Science and Engineering. In an office, Melanie sits in an office chair.
Hi, I am Melanie Sclar. I'm a third-year PhD student working with Yejin Choi and Julia Cvetkop in natural language processing.
Melanie walks past a brick wall which bears a sign that reads Paul G. Allen Center for Computer Science and Engineering. She enters the building through sliding glass doors.
I realized that I really wanted to make an impact in the world, so I switched from being a pure mathematics undergrad to a computer scientist.
She arrives at the office, takes her seat at a desk, opens up her laptop to a screen which displays code and begins to type.
This is a great moment to be doing NLP research. Things are changing very rapidly. I focus specifically on reasoning of large language models and trying to improve reasoning capabilities.
Through the slats in her office window, Melanie types on her laptop which connects to a monitor.
One type of reasoning that current large language models don't do very well is theory of mind reasoning.
Melanie sits in her chair and gestures as she talks.
Theory of mind is the ability of reasoning about mental states of other people.
Melanie works at her desk with her laptop and the attached monitor. Her laptop displays an icon of a man, an icon of a woman with a red apple overlaid, a basket icon and a blue box, as well as a timer. The monitor displays the same icons in the text Salian test, Wimmer, and Perner, 1963. Baron Cohen et al., 1985.
A short story that people usually use to test theory of mind capabilities is called the Salian test.
Melanie stands before the whiteboard and holds the red marker. She draws a stick figure which she labels Bob, and next to it a stick figure which she labels Alice. She draws a basket under Bob, and a box under Alice.
Say Alice and Bob are in a room where there is a basket and a box.
She draws an apple next to Alice.
Alice has an apple. Here.
She erases the apple, redraws it in the basket and then erases Alice.
She puts it in the basket and then leaves the room.
She erases the apple from the basket and redraws it in the box.
Now Bob will come and moves the apple from the basket to the box. So the questions that then will ask either a person or a model to probe their understanding of theory of mind reasoning is as follows. Where does Alice think that the apple is? Where does Bob think that Alice will be searching for the apple when she comes back? Where does Bob think the apple is? And those questions do not all have the same answer, but language models will always answer box.
Text on the monitor in Melanie's office reads, Salian test, Wimmer and Perner, 1983, Baron Cohen et al., 1985, Anne and Bob are in a room where there is a basket and a box. Anne puts an apple in the basket and then leaves the room. Bob then moves the apple to the box. 1. Where will Bob search for the apple? Answer, box. 2. Where does Bob think that Anne will search for the apple when she comes back? Answer, basket. An arrow which points to question 1 features text, first order, true belief question. An arrow which points to question 2 features text, second order, false belief question.
The reasoning that's missing is understanding that what you may know might not match what I know.
Melanie sits in front of the monitor which now displays the text, graphical global state tracking. The monitor also displays the prompt and question 2 on the left side of the screen. On the right side of the screen, the word apple appears in a box with a line labeled with the text, is in. The line leads to the word box. A line labeled, is in, coming out of the word box leads to the word room. The words basket and Bob also appear with lines labeled, is in, which lead to the word room. A box with the word and stands apart. Underneath the chart the text, global context, G, is written in red.
So what people usually do when they're modeling a short story is they have one giant graph that's representing the whole story, all at the same time.
A red box appears diagonally over the chart with the text, not enough information.
But if you want theory of mind reasoning capabilities, this is just simply not enough information.
The monitor now displays an icon of a man's head labeled Bob. 2 thought bubbles come out from his head to the left and right. The left bubble contains the word apple with a red line labeled, is in, which leads to the word box, which has a black line labeled, is in, coming out of it leading to the word room. The bubble also contains the word basket. A line which leads out of it displays the label, is in, then leads to the word room. Under the bubble in blue appears the text, where will Bob search for the apple? The right thought bubble contains the in icon with a thought bubble which comes out of her head. Ands. Bubble contains the word apple with a red line labeled, is in, which leads to the word basket, which has a black line labeled, is in, which comes out of it and leads to the word room. Ands. Bubble also contains the word box which features a black line which comes out of it labeled, is in, and leads to the word room. Under the bubble in blue appears the text, where does Bob think that Anne will search for the apple when she comes back?
So we'll have several graphs. For example, one graph that says where will Bob search for the apple, so the beliefs that Bob have. Another graph for the belief that Bob has about Anne's beliefs.
The monitor now displays a screen titled, Symbolic Tom's Overview. A text box on the left reads, where does Anne think that Bob will search for the apple? Two arrows come out of the box. The upper arrow points to the text, where is the apple? Which points to a robot icon with a speech bubble which comes out of it and contains the text, basket. The lower arrow points to a box which contains a chart. The chart features the word apple with a line which comes out of it labeled with the text, is in. The line leads to the word box. A line labeled, is in, comes out of the word box and leads to the word room. The words basket and Bob also appear with lines labeled, is in, which leads to the word room. A box with the word and stands apart. An arrow which comes out of the chart points to the text, Bob is in a room, where there is a basket and a box, the apple is in the basket. An arrow which comes away from the text points to the robot icon. Text on the bottom of the display reads, 1. Detect entities in question, retrieve belief graph and perform. 2. Retrieve sentences captured by the graph. 3. Feed to language model.
So this is what you feed to the language model, and we find that by doing this procedure, you can improve the performance on a theory of mind dataset by, for example, 60 points in accuracy.
Melanie types on her laptop.
Having reasoning abilities that we can trust will become very important as we deploy these models into the real world. So the Allen School for NLP is like the holy grail. It has a lot of people doing great work and very diverse work too.
Melanie types on her laptop which displays code.
Not only that, but also we get to collaborate quite often with other institutions. So it's a big place to be doing AI. My name is Melanie Sclar, and I am CSE.
Text, Paul G. Allen School of Computer Science and Engineering. cs.washington.edu. Copyright Paul G. Allen School of Computer Science and Engineering, University of Washington, 2023.